Example 4 says a box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimize the amount of material used. Again, let us draw that picture. So here is our open box with no top. All right, so there is our box. It has a square base, so I'm going to call this S, S, and then the height, we don't know what the height is, but that's going to be a different length potentially than the side length, so let's call that H. And we know that the volume must be 32,000 cubic centimeters, and so the volume of this particular box is S times H. And so if we rewrote that as S squared H, but the volume must be 32,000. So if I replace V with 32,000, then we have S squared H is equal to 32,000. Now, the thing that we're trying to minimize is the amount of material used. And that's another way of saying the surface area. And the surface area for this particular box is basically the areas of all the faces. So how many faces do we have? We have the bottom face, so this square here, we have that face, and then on top of that, we have the 4 side faces. And normally, if this was a closed box, we'd have the top face, but this particular box does not have a top. So we are adding up the area of 5 faces, so the bottom face plus the side faces. So the bottom face has an area, it's a square, so it's S squared. And then each of the 4 side faces, those all have dimensions S by H. So SH plus SH plus SH plus SH. And those represent the 4 sides. So if I combine that, then the surface area is going to be S squared plus 4SH. And since surface area is the thing that we're trying to minimize, that's going to be the thing that we end up taking the derivative of. However, we can't do that because currently there are 2 variables. We have S and we also have H. So what we need to do is we need to use this equation, which, as a reminder, is usually called the constraint. And so if I use the constraint equation to solve for H, we end up getting H is equal to 32,000 over S squared. And now I can substitute this value in for H right there. So if I do that, then we get the surface area is equal to S squared plus 4S times 32,000 over S squared. And if we simplify that, we get the surface area is equal to S squared plus 4 times 32,000 is 128,000. And then one of the s's in the numerator will cancel out with one of the s's in the denominator. So we would have one s in the denominator, but I'm going to rewrite that as s to the negative 1 power. Now, if we're going to minimize the surface area, I'm going to go ahead and take the derivative of it. So we get 2s minus 128,000 times s to the negative 2 power, which if we rewrite that, that's 2s minus 128,000 over s squared. And we want to find a common denominator. So I'm going to multiply this by s squared over s squared. And if we do that, then we get that the surface area is equal to 2s cubed minus 128,000 over s squared. And we want to set that equal to 0. So if we set that equal to 0, then we just set the numerator equal to 0. So we get 2s cubed minus 128,000 is equal to 0. And we want to solve for s. So I will add 128,000 to both sides, and then divide both sides by 2, and we get s cubed is equal to 64,000. And then if we take the cubed root of both sides, we end up getting s is equal to 40. So the original question is asking for the dimensions of the box. So we have one of the dimensions. We have 40 centimeters. And then we want the height of the box as well. So the way that we can do that is by using the constraint function that we had, or the constraint equation. So we had 32,000 is equal to s squared times h, but we've now solved for s, so we can plug in 40 squared for, 40 for s. And if we simplify that, we get 32,000 is equal to 1600 h. And then if we divide both sides by 1600, we get that h is equal to 20 centimeters. So I forgot to double check whether 40 was a min or max. So let's use the first derivative test. So here's 40, and I can use 10 as my test number. So 10 as a test number and maybe 50. So SA prime of 10 is equal to, let's see, 2 times 10 minus 128,000 over 10 squared. That's going to be 20 minus 1,280. So that's definitely going to be negative. So this is negative. And then let's find SA prime of 50. And that is equal to 2 times 50 minus 128,000 over 50 squared. That's going to be 100 minus, what's 50 squared? 2,500. So 128,000 over 2,500. And that's 100 minus 51.2, which is greater than 0. So this is going to be increasing. And therefore 40 gives us a relative minimum, which is what we want. We wanted to minimize the amount of material used. So finally we can say the dimensions that minimize surface area are 20 centimeters by 20 centimeters by, oops, that's not right. It's 40 centimeters by 40 centimeters by 20 centimeters. So that is our final answer for this example.